Hello everyone, in this series tutorial number 67 I will present a schematic which provides a pure phase shift, which means a shifted signal but with a constant amplitude. To do this circuit providing a pure phase shift from minus 180 to 0 degrees compared to Vin, we start with a well-known first-order high-pass filter. We remind the gain and the main characteristic of this RC high-pass filter with the schematic and the curve around the cutoff frequency with half and double cutoff frequency typical point. For the cutoff frequency f, we can start with a vertical Vin vector equal to 1. Then we plot the sum of vector Vout plus Vc equal Vin to get a phase of 45 degrees and an output amplitude of 0.7 or minus 3 dB. We do the same construction for the cutoff frequency f divided by 2. We will get a phase of 63 degrees and an amplitude of 0.44 or minus 7 dB. Then we do the same thing for the double cutoff frequency 2f. We will get a phase of 27 degrees and an output amplitude of 0.89 or minus 1 dB. We can remark that the 90-degree angle of each triangle are placed on the circle of radius 0.5. Now, if we reshape the high-pass filter schematic as shown, and we add a resistor divider to provide the signal Vin divided by 2, we can plot the red vector Vout minus half Vin on the schematic and also the vector position on the vector construction. At low frequency, Vout equal almost 0, so the red vector is directed to the downward with an amplitude of 0.5 and a phase of minus 180 degrees compared to Vin. If we look the red vector at different frequencies, we will see that at the frequency f divided by 2 with Vout equals 0.44, the red vector has a phase of 54 degrees compared to the minus 180 degrees at low frequency, but with always an amplitude of 0.5. On the left, a representation shows the same vector in the time domain. For the frequency f over 2, the red signal represents the signal shifted of 54 degrees with an amplitude of 0.5. We do the same for the frequency f and 2f with a respective phase of 90 and 126 degrees up to the highest frequency with a 0 degree shift compared to Vin. Now we can visualize the constant amplitude vector rotation from minus 180 to 0 degree phase with a constant amplitude and check that in time domain the red signal has the same amplitude for all frequencies. I want to thank you for your attention. On my next DRC tutorial number 68, we will compare the gain error in a closed loop system versus the open loop phase. So see you soon and stay tuned.